Let's talk about the four fundamental forces in the nature. First one is the gravitational force. Second one is the electromagnetic force. And the third one is the strong nuclear force. And the fourth one is the weak nuclear force. Now let's talk about this famous force called the gravitational force. Gravitational force is the force of mutual attraction between the two objects due to their mass. It's the mutual attraction between the two objects due to their mass. It is the universal force. Every object in the universe experience this force. Now, let us consider our solar system. In our solar system, we have the sun in the center and nine other planets, nine planets revolving around this sun. Nine planets revolving around this sun. Why these planets revolve around the sun only? This is because of the gravitational force. Now let's talk about the second force, that is electromagnetic force. Force. This electromagnetic force is the force between the charged particles. Okay, this electromagnetic force is greater than the gravitational force. Now questions come in our mind is that how much greater than the gravitational force. This electromagnetic force is 10 raised to 35 times greater than this gravitational force. Now the next questions comes in our mind is that we are experiencing the gravitational force but we are not experiencing the electromagnetic force. We are experiencing the electromagnetic force also. Now let's take an example of egg. Okay, we are holding the egg in our hand. We are feeling it as a so lightweight. Why we are feeling the egg as a lightweight? Wait, because of the electromagnetic force. Because of this electromagnetic force, we are not experiencing the gravitational force which is acting on the egg. Now let's assume something. Suppose you are walking on the road. Okay, then the all the electromagnetic force from this world is removed. Then what will happen when the all the electromagnetic force is removed from the world? Now you are going in this direction. Then if suddenly electromagnetic force is removed, you will be like omelette. One important note is that the electromagnetic force is not like the gravitational force. What happens in gravitational force? Gravitational force is always attractive, but the electromagnetic force is not always attractive. Electromagnetic force is attractive as well as repulsive. Why it is attractive as well as repulsive? Because as I told in the definition of the electromagnetic force, the electromagnetic force is the attraction between the charged particles. The charges are not always positive. The charges are positive as well as negative. So it's attractive as well as the repulsive. But in case of the gravitational force is depends on the mass. So the masses are always positive. Hence this gravitational force is always attractive. Now let's talk about the strong nuclear force, which is the third force. This strong nuclear force binds the proton and neutrons inside the nucleus. We know that the nucleus consists the protons and the neutrons. Around these protons and the neutrons, there will be lots of electrons which is negatively charged. These electrons are negatively charged, and the protons present here is the positively charged. Proton is positively charged. So I told earlier while studying the electromagnetic force, the electromagnetic force are attractive as well as repulsive. So the protons present in the nucleus is consist of the positive charges. So there will be so much of protons. As we know that the opposite charges attracts each other. So the positive charges and the negative charges are attracts each other, and the same charges repulse each other. Here the protons consist the same charge, that is positive charges. Hence the protons inside the nucleus will repulse each other. In order to bind these protons, we need a strong force which is stronger than the electromagnetic force. This force is the strong nuclear force. The strong nuclear force is so much stronger than the electromagnetic force is that it neglects the electromagnetic force. How much is the strong nuclear force is stronger than the electromagnetic force? The strong nuclear force is 100 times stronger than the electromagnetic force. Now let's talk about the last force, that is weak nuclear force. This weak nuclear force is not the weakest force. It is stronger than the gravitational force but weaker than the electromagnetic force and the strong nuclear force. So the gravitational force is the weakest force. After the gravitational force, there will be a weak nuclear force. Weak nuclear, and then electromagnetic, and then strong nuclear force. This weak nuclear force has the range of 10 raised to minus 16 meters.